All right, so we got this problem from Reddit, and Reddit's got a lot of great problems that people post. And typically, I think it's from high school. I think it's from an 11th grader, and the 11th grader says, "I don't know what to do." And I understand it too. I understand people look at these problems and say, "I don't know even where to start this problem over here." I think a place to start the problem is to read it. And it says, given that T1, T2, T3 is an infinite geometric sequence, find the common ratio R if that Tn, that's the nth term of this geometric sequence, divided by the infinite sum minus the finite sum is equal to 2/3. All right? Some assumptions are being made over here. And I want to point out before I go to the whiteboard, the assumptions are being made over here that T1 is not equal to 0. Because if that's the case, every term would be 0, and there'd be no way this is sum to 2/3. The other assumption, if it's convergent, there is an S infinity, and the only convergent if the R, the absolute value of the R, is less than 1. All right, that's for convergence. All right, let's go to the whiteboard, and let's go through it. And I'll write it down. And what are we writing down over here? One thing I'd write down is what they've given me, and they've given me this over here, Tn over S infinity minus Sn, that's the nth partial sum, by the way, is equal to 2/3. And they say for all n. Now, what kind are they talking about? 1, 2, 3, blah, 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 blah. All right? So, again, conditions are T1 is not equal to 0. R is not, oops, I'm sorry, I shouldn't say not. I could say that, but I'm saying R, that R is a proper fraction. The absolute value of R is a proper fraction. All right? So the first thing I'd write down is some formulas that I know for geometrics. And this is geometric. What do I know? I know Tn, and you would need to know this if you're going to do the problem, is going to be T1 times R, where R is called a common ratio. S infinity, provided the conditions are being met, would be equal to, let's write this down, it's going to be, the infinite one is going to be T1 times 1 over 1 minus R. And Sn is going to be T1 times, and you would need to know this, 1 minus R to the n, 1 minus R. All right, that's all you need to know. I'm going to plug it in now. And I'm sorry, I made a mistake already. This is n minus 1. Sorry about that. Let's take a look. Let's write it down. What's the top going to be? T1 times R n minus 1. What goes on bottom? Oh, by the way, we're trying to find R. All right, right now I got way too much information down. I got T1 and what that is. I don't know what n is, and I don't know what R is. There's three unknowns there. Let's go to the bottom. What's S infinity? Well, it's going to be T1, and then you can get 1 over 1 minus R, and then it's going to be minus, well, what's Sn? It's T1, and then I get 1 minus R to the n over 1 minus R. Well, the first thing I'd probably do is I realize that the T1s are going to cancel out. They're common factors between top and bottom. And T1's not equal to 0, so I can easily cancel it off. What I left off with R, n minus 1. And what do you get on bottom end? 1 over 1 minus R minus, again, I'm dividing by T1. This would be 1 minus R to the n over 1 minus R. And that's equal to 2/3. All right? The next thing I'd probably do is multiply top and bottom by 1 minus R. Let me write that down for you. So you can get R, n minus 1, 1 minus R. Now, the reason I'm multiplying by 1 minus R, it gets rid of the complex fraction. That's going to give me 1 minus 1 minus R to the n. Now, things are shaping up a little bit. I want to simplify the bottom, and you get R, n minus 1, 1 minus R. And on the bottom, what do you get? You get 1 minus 1, which is none, and minus a minus is plus, so you get Rn. And that's still equal to 2/3. All right, I'm going to reduce it now. And you get 1 minus R. And I'm looking at this over here. Do you want to reduce that? That would just give you an R in the bottom. And that gives you 2/3 now. I'm going to clear the fraction. It's going to give you 3 minus 3R. equals 2r. 3, I'm going to add 3r to both sides, is 5r. And what do you get over here? You get 3 over 5r. But I want to go back to the restriction to make sure that restriction is being met, by the way. And the restriction that needs to be met is that the r is a proper fraction, the absolute value of r is a proper fraction. And that's certainly true, by the way. So what's the answer over here? R equals 3/5. And we are done. All right? Thank you for paying attention.